Hello students, and welcome to the section 9.3c video, which is about area of composite figures. By the end of today's lesson, you will be able to find the area of various composite figures. So we talked about in lesson 9.3a, that last one we did in school together, that composite figures are made up of more than one shape. So it's going to be more than one shape put together to make a bigger space. Just a quick review of all the different area formulas that we have covered. First, the area of a parallelogram, which also works for rectangles, for rhombi, and for squares. So all of these different shapes all have the same area formula, and that is area is equal to base times height. For the triangle, our area formula, recall, was area is equal to base times height divided by 2. For the trapezoid, we had area is equal to base 1 plus base 2. Remember, that was in parentheses, times the height divided by 2. Our area of a circle formula was area is equal to 3.14 times the radius squared. Remember, radius being halfway across the circle. And then our formula for a semicircle was area is equal to 3.14 times the radius squared divided by 2. Remember, that's because we were only looking at half of the circle, which is why we are dividing it by 2. So now we're going to get into examples of how to use these formulas in composite figures. Again, you are just putting them together to make new shapes. When you are doing this, you want to break these big figures, so those composite shapes, into the smaller figures that we know the area formulas for. So breaking them into one of these 5 possible shapes. This first problem, I've got this figure right here, and I'm going to go ahead and notice that I can break it into the first part of a semicircle, and then the second part being a rectangle. So those are the 2 shapes that I can break that composite figure to. For the semicircle, I'm just going to denote it as the semicircle area. I have to do pi, 3.14, times, now I need the radius. So I need to know how long this piece is right here. In order to find that, I'm going to first figure out how far it is all the way across. In order to do that, I'm going to take my 9.2 and I'm going to subtract 2.5 because the whole way across is 9.2 and this little chunk outside the semicircle is 2.5. When I do that subtraction, I'm going to end up with 6.7. Now, I mentioned that we only want the radius. So that 6.7 then, I'm going to have to divide by 2, and that is going to give me 3.35. So my radius is 3.35 centimeters. So then in my problem, I've got 3.35 squared, which remember is 3.35 times 3.35, and then I'm dividing that by 2. So that's going to give me my area of my semicircle. Type it in, 3.14 times 3.35 squared divided by 2, which is going to give me an answer of 17.62 centimeters squared. So that's how much is on the inside of that semicircle. The next thing I'm going to look at is my rectangle now. So I'm just going to say the rectangle and the area. So the area of my rectangle is the base, which is 9.2, times the height, which is 1.5. When I multiply those values, I'm going to get an answer of 13.8 centimeters squared. Then to finish the problem, to find my total area, I'm going to do 17.62, the answer for the orange part, plus 13.8, the answer for that green outlined rectangle. And I'm going to find that my total area then, you're going to want to write total area, is going to be 31.42 centimeters squared. So that's the total area of the whole shape all put together. I want you to go ahead, try to break this one up into two shapes, and then find the area on your own. So the two shapes here are going to be the triangle and the rectangle. For the triangle, again, you need to find that base. We're going to do that by doing 10 minus 6 to give us that 4-inch base. So we've got 4 times 4 divided by 2 is 8 inches squared. The rectangle part is base times height, 6 times 10, gives you 60 inches. Adding it up, you get a total of 68 inches squared. Some of them are going to be a little bit more complicated. So looking at this one, you could potentially split it up into 3 shapes. So you could say you have your first trapezoid, you have your second trapezoid, and then you have this rectangle in the middle. That would be one option. That is what the design makes it look like would be the easiest. But sometimes you need to look at it and say, okay, is there any easier option? So if I cut right here at the top, I would have a rectangle down at the bottom, and I would have just one trapezoid to deal with then. Just one trapezoid up here on the top. So you could break it into the 3 different shapes. Personally, I'm going to break it into just these 2 shapes. So the one measurement we're missing then is the height of this trapezoid. If the whole height was 20 and the rectangle height was 14, I've got my height is 20 minus 14, or 6 feet, because then this portion down here is just 14 feet. So then, to find the area of my trapezoid, so my trapezoid area, I'm going to say I've got base 1, so that bottom part, which going all the way across here, is 36 feet. So I've got base 1 plus base 2, that top part, which is 20, times the height, which we figured out was 6, divided by 2. When I plug that into the calculator, I am going to get an answer of 168 feet squared. So that's going to be my area for that trapezoid. Then I need to come down and figure out the area for my rectangle. Again, that's going to be base times height, the base of the rectangle being 36, the height of the rectangle being 14, giving me a total area there of 504. Again, then to find our answer, we're going to take our first answer plus our second answer, which I should have included a label on, remembering that the labels here are feet squared. And I'm going to then find that my total area for this shape is going to be 672 feet squared. So that's going to be my total area for this shape. Go ahead and break this one into 2 shapes and solve on your own. So you have the tiny little trapezoid off to the side and then the giant rectangle on that right side. Tiny trapezoid, base, add those together, times the height, divide by 2. And then our rectangle, we've got base times height. And when I add those together, I get 402 feet squared. Last thing I want to address with you is what happens if there is an overlap. So in this one, I have this first shape, which I'm going to use, and I'm going to find the area of that first red part by doing base times height, which is going to be 144 centimeters squared. So that would take care of all of this. Then I would have my second shape, which once again, I can find the area of that using base times height, which is 15 times 12, which is going to give me 180 centimeters squared. But then notice that that means that this chunk right here, this blue part, has been counted twice. It's been counted as part of the green shape and as part of the red shape. So if you have an overlap, you need to take a final step and you're going to have to subtract that area out. So if I'm looking here, this part right here is 6, which means this part right down here is also going to be 6 centimeters for that total of 12. Looking across, I've got 8 centimeters here, which means I've got 7 centimeters left over there to get to my total of 15. So my base times my height of this one is going to be 7 times 6, which is 42 centimeters squared. Then to find my total here, I'm going to take and I'm going to add like normal, so 144 plus 180, but then I have to subtract off that overlap area, so it only gets counted once. So I subtract off the 42, which is going to give me a total area of 282 centimeters squared. If you have questions about this or anything else from the video, please feel free to shoot me an email and I will respond to you as quickly as I can.